Hello students, firstly I welcome all of you once again to this class. Today we'll be solving few questions from your chapter triangle. This is exercise 7.1. Okay, before we start the class, let me just remind you all the conditions of the congruency of triangles. Sufficient conditions. We have side, side, side. Next we have side, angle, side, angle, side, angle, 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 side, and right hypotenuse side. If any one of these conditions is satisfied, then we can prove that the triangles are congruent. So now let's begin. This is your question before. L and M are two parallel lines. So this line and this line, these two are parallel lines intersected by another pair of parallel lines P and Q. Intersected means cut. These two lines are again intersected by the another pair of parallel lines. This is P and Q. That means these L and M are parallel to each other. At the same time, this line P and Q are parallel to each other, and the pair of the lines are intersected. Okay, now we have to prove that triangle ABC is congruent to triangle CTA. Okay, so let's follow the procedure. First, let me write the given. Here is your given. Okay, I will not change anything how it was given. I'll just follow that exactly. And next we have to prove. To prove. So to prove is here. Okay, now let's begin. Let me show you the two triangles first. Triangle ABC is congruent to triangle CDA. Okay, so now let me start proof. First, let us prove that the quadrilateral ABCD is a parallelogram. Okay, one basic property for the parallelogram is the pair of the opposite sides. So this side and this side, they are opposite, and these two will be always parallel. At the same time, even the length of the opposite side will be equal. So these two are parallel. At the same time, if this one is 5 centimeter, its opposite is this, so this also will be 5 centimeter. Similarly, even this also parallel. At the same time, if this one is 10 centimeter, this also will be 10 centimeter. So let me repeat. In case of the parallelogram, the length of the pair of the opposite sides are equal, and the opposite sides are again parallel. Okay, now let me write here in quadrilateral ABCD. I'm writing here in quadrilateral ABCD. ABCD means this quadrilateral ABCD. Here I can say that AB parallel to CD. Let me repeat. I'm writing here AB is parallel to CD. Why? The reason is this line P is parallel to this Q. So if any two lines are parallel, so this is, let me say here P and here is Q. Now these two lines are parallel. That means even, let me just take any segment here. Let me name it here AB, and this is CD. Even AB and CD will be parallel. So let me repeat. If any two lines are parallel, now P and Q are parallel lines, that means even the segment AB, the line segment AB will be definitely parallel to the line segment CD. So the similar situation happens here. This line P and this line Q are parallel to each other. That means even the segment AB will be definitely parallel to CD. Okay, then we have to write here, since line P parallel to line Q. Okay, next we have BC also will be parallel to, you please see properly, this is BC and this is DA. BC will be parallel to DA. BC will be parallel to DA. What is the reason here? Since this line L is parallel to line M. Okay, that means here in this quadrilateral, the pair of the opposite sides are parallel to each other. That means ABCD is a parallelogram. So therefore ABCD is a parallelogram. Now we are going to prove these triangle ABC and triangle CD are parallel. Okay, so before that, let me just write in this way: AB is equal to CD, because they are the opposite side of the parallelogram. AB equal to CD, and next we have BC equal to DA, and I'll write the reason here. Pair of the pairs of the opposite sides of parallelogram are equal in length. Okay, now AB equal to CD and BC equal to DA. Now let's compare now. AB, in this triangle ABC, AB means this one, AB is equal to CD. One side of the triangle is equal to the another side of the triangle. Okay, fine. Next, BC equal to DA. Please, ABC, ABC, CDA, CDA. This AB is equal to CD. Next, BC is equal to AD. Or you can say DA, nothing wrong in that. And one more, this AC is a common side. AC is a part of the triangle ABC. At the same time, this AC is a part of the triangle CDA. So that's how we can prove that the two triangles are congruent by SSS congruency rule. So now let me just rub this part. Okay, I'll just start here. In triangles A, B, C and C, D, A, let's compare. AB is equal to CD. AB equal to CD. We prove already, actually we prove above. So you can write here, prove above. Next, BC equal to DA. So BC equal to DA. Here also you have to give the same reason here, prove above. We prove here. And then last, you can write here AC equal to AC. This is actually nothing but common side. Okay, therefore triangle ABC is congruent to triangle CDA. What is the congruency rule that we use here? This is side, side, side. So we can write here by SSS congruency rule. So hence proved. we'll move to the next question. Okay, here's the question. Question number 5. Line L is the bisector of an angle okay, of an angle A. Okay, fine. There is an angle A. There is the angle A. What is that? I'll just draw here. This is your angle A. This angle A, fine. And B is any point. Sorry, angle L is the bisector of an angle A. This is angle A, and this line L is the angle bisector. That means this angle is equal to this angle. Let me say here angle 1, angle 2. Angle 1 equal to angle 2. This line L bisects this angle A. That means there will be here two angles of equal measure. So I write here angle 1 and angle 2. Don't forget angle 1 equal to angle 2. Why? This L bisects this angle A. That means this is the angle bisector. And next, and B is any point on L. So B is, even you will find here, I'm just explaining you here, B is any point on the line L. Now this is B, okay. BP and BQ. BP and BQ are perpendiculars from B to the arms of angle A. So you please understand what is the meaning of arms of angle A. This is angle A, right? This side and this side, these are what we call arms of the angle. So this is also one arm, and this also another arm, and this BP and BQ are perpendiculars from B to the arms of angle A. That means these are the two arms, and BP and BQ are the perpendiculars drawn from B. Okay, now there will be 90 and there will be 90. The figure shows everything here. Okay, now we have to prove so that triangle APB is congruent to triangle AQB. And next is BP equal to BQ. BP equal to BQ, or else B is equidistant from the arms of angle A. So let me explain you what is the meaning of equidistant. There is a line segment here. I'm just taking a point here. So this is point A, and I have taken here one more point again here, B, and again one more point here, C. From A to B is 5 centimeter. Again from A to C is 5 centimeter. That means these point B and C are at equal distance of 5 centimeter from this point A. That means B and C are equidistant from A. So similarly, B is equidistant from the arms of angle A. That means BQ or BP is equal to BQ. It's same meaning, only they just give the words, they express in different way. Okay, now let's begin. So I'll just write the given here. Given. So I will not change anything till here is given, and this is your to prove. Okay, now let's begin. Before we start, let us see properly how are we going to prove the triangle APB and triangle AQB are congruent. This is APB, and next is AQB. AQB. Let us identify whether some angles are equal or some sides are equal. We have seen very clearly here, this is 90 degree and this 90 degree. At least this Q and P, that means angle P and angle Q are equal. Fine, okay. Next we have this L is the angle bisector. That means this angle will be equal to this angle. This angle means, QAB, and the next one is this PAB. So here I'll give here angle 1 and angle 2. Angle 1 and angle 2 are equal. Why? This L bisects angle A. Next we have, even AB is a part of this triangle APB. At the same time, this AB is a part of the triangle AQB. So when we see here, one condition is satisfied: angle, side. So by angle side congruency, we can prove that triangle APB is congruent to triangle AQB. Now let's begin. So this is angle A. Okay, now proof. In triangles APB and AQB, we can say here angle P, this angle P equal to angle Q. You can say here 90 degree. It's next we have angle 1 equal to angle 2. The reason to be given here is this angle, this line L bisects angle A. So you can say here line L bisects angle A. And next we have one more, this AB equal to AB. The reason to be given is common side. Therefore, triangle APB is congruent to triangle AQB. Here, what is the congruency rule here? The space is not there actually, but you can just write here by angle side congruency rule. Okay, so now the first proof is done. This is your first. Now we'll move to the second one. So let me just rub this part. Second, I can say that even in the second case, triangle APB congruent to triangle AQB. Triangle AQB. You can say here proof above. Okay, this is BP and this is BQ. BP means second and the last, and here BQ means second and the last only. So these BP and BQ are corresponding sides of these congruent triangles APB and AQB. So you can say here, therefore BP equal to BQ. So you can just write here CP CT. Okay, that's how we have done the proof. Hence proof. Okay, please have a look at here. This is B is equidistant from the arms of angle A. That means you can simply just write here, that is B is equidistant from the arms of angle A. So hence proof. Okay, we'll move to the next question. Okay, here is the question. Question number 6. In figure 7.21, this is actually as per the textbook 7.21, the figure number, and AC equal to AE. AC, here double marking, equal to AE. So these two are equal length. And next is AB equal to AD. AB equal to AD. Okay, and again BAD. Where is BAD? BAD. It's even marked in the textbook as well. This BAD equal to EAC. These two angles are equal. So we have to prove that BC is, this is BC, and BC equal to DE. Okay, please have a look. We are going to prove that BC equal to DE. We have to find out the two triangles. We have to extract two triangles from this given figure, and we have to prove that the two triangles are congruent again. So in that two triangles, these BC and DE should be actually corresponding sides. So how we are going to find? Okay, so please have a look at here. I'll just take this triangle ABC. Let me take here ABC, and next I'll take ADE. Okay, so my question is, are we able to prove these two triangles are congruent? So let's see here. AB, okay, AD, at least one the one side of this triangle is equal to the other side of the one side of the another triangle. Fine, okay, and you can see even from the figure itself, this AB is equal to AD. Okay, now one side is okay. Next we have this AC is equal to AE. Another side we have actually, and these two sides are not sufficient enough to prove that they are congruent. Okay, please have a look properly. Let me take out the triangles now. This ABC I'll draw here. A, B, C, and next I'll draw this triangle A, D, E. So this is little like this. A, D, E. So let us mark one by one. AB is equal to AD. Okay, so these two sides are equal. Next we have AC is equal to AE. Okay, AB equal to AD, AC equal to AE. But if we are able to prove this angle is equal to this angle, then we can prove that by side angle side congruency rule, these two triangles are congruent. Okay, now let's see, is there any way? Okay, I'll give this angle is angle 1 and this is angle 2. Let us prove that angle BAC equal to angle DAE. Okay, let's see how we are going to prove. So let me just write here, this is your given. Okay, given, and next to prove BC equal to DE. BC equal to DE. Okay, so I'll start the proof here. Proof. Angle 1 equal to angle 2. Angle 1 equal to angle 2 means this is BAD. So let me just leave it this one because the question tells very clearly. It's fine. Angle BAD is equal to angle EAC. You can write here like this. Given. Okay, next. In both the angles, let us add the angle DAC. Let me repeat. In to both the angles, let us add this angle DAC. So angle BAD plus angle DAC. I'm adding angle DAC on the left hand side. That means even on the right hand side, I need to add this angle DAC. So what I'm doing here now, you please give the reason here. So I'll write here, adding angle DAC on both the sides. So next we have angle BAD, angle BAD plus DAC. DAC, that means it goes up to here. So we have angle BAC. Next, on the right hand side, EAC, this angle, then I'm adding DAC. DAC, that means we are talking about this angle. So this is DAE angle, DAE. Now BAC, BAC, this angle is equal to DA, this is your E actually. So by side angle side congruency rule, we can prove that the triangles are congruent. Okay, now we'll start. I'll just continue. So in triangle BAC, in triangle BAC, okay, let me just put triangle BAC and DAE. Okay, now what are the sides equal here? Let us please look at the given ones. AB equal to AD. So let me just start with it. AB equal to AD. This is given. Next we have angle BAC equal to angle DAE. You can write here, proved above. Next we have AC equal to AE. AC equal to AE. So I'll just continue here. Let me rub this part. Therefore, triangle BAC is congruent to triangle DAE. DAE. What is the congruency rule here? This is side angle side, so SAS. So we can say here, by side angle side congruency rule. Okay, now we have proved that these two triangles are congruent, but we are supposed to prove BC equal to DE. BC equal to DE. BC means first and the last, and DE means first and the last. So that means BC equal to DE. Why they are equal? Because we have to give the reason here, CP CT. Okay, now we have done our proof. So this is hence proof. Students, thank you so much for watching the video. I hope that you'd be learning something today, and we'll see you again in the next class. Thank you.